Now, here's a video to help you with exercise 12.2. It's to do with finding levels. So when you're doing building, you often need, well, always need, your poles to be at equal height to one another, because otherwise the floor that sits on them is going to be sloping, and that's no good. Now the problem is, the poles are anchored into the ground, which is rarely ever perfectly level. So just this page here, page 359, gives some examples of different ways of finding levels, like spirit level, level line, water level. It's worth having a read through them. It's quite interesting to see different ways you can find levels and the benefits and disadvantages of each. But we're going to be looking at doing these things, these optical levels. So you have this type of device here, and you can see it mounted on a tripod in this particular diagram. Now, on this diagram, there's a few things that you need to know about. Here, this is called the staff, the leveling staff. It's got heights marked on it. And so you look through your device and you can read off the height that the staff is above the ground there. Over here, this is called the datum. On any particular building site, there'll be a datum, usually the lowest point, and all heights can be taken from that because it's a known height, usually been surveyed. This line here, the line of collimation, this is a straight line going back and forth through your optical device. Now in this particular example, you want to find how much the land rises from point A to point B. So you set up your device here, have a particular leveling staff, you look forward and see that that point is 1450 mil above the ground. Look back through the back line of sight, that point is 2870 above ground, so therefore clearly the height that it's risen is going to be the subtraction of those two figures, which is done here. So land rises 1.42 metres. If you want to trace it out, starting from the datum, you rise up 2870 to the line of sight, across the line of sight to the next staff, and you drop back down 1450 mil back to the ground that you want, hence the subtraction. If you want to work out the angle of rise of the ground as well, once you've drawn a diagram here, we can see here the ground rises 1420. You get your tape measure out, you can measure up the hill 24 metres, that's put there as the hypotenuse. You can work out the angle by the sine ratio, and the angle is approximately 3.4 degrees. So that's the type of question you're going to come across. It gets a little bit more complex. You have a look at one of the exercises. So you can see here, if you want to find the rise from point A to point C, you simply won't be adding the 4.72, 5.6, the 1.45, etc. You need to do a bit of calculation and work out what you've got. For example, on this particular one, from point A, you rise up 4.72 to the line of sight. Then over to here, from that point there up to the top, that distance is not 5.64. The 5.64 refers to how far that point is above the ground, point B. The 1.45 refers to how far it is above point B. So if you then want to rise up 4.72, come across to here, and then rise up again, you're rising up the difference between those two figures. So you would subtract them, and that would be your new rise, added on the 4.72, come across, you're now 0.75 above the ground, which of course you then need to subtract to bring you back down to the ground. So there's a whole lot of adding and subtracting that needs to be done. You need to trace your way through this. Up the 4.72, across to here. This particular distance is going to be the big distance, take away the little distance, and that's what you'll then add on, and then of course take away that. It gets a bit complicated, but if you work through slowly and methodically, you'll be able to work out the rises without too much difficulty. Now the only other type of question you're going to come across is ones like here on example 4, where you've got guttering, and you're told that for guttering to work effectively, for the water to run down the gutter, it has to have a fall of 1 in 500. So the question says the house front has got a 16.4 metre wide front. If it's a 1 in 500 drop, how much does the gutter need to drop from the front, from the top corner to the bottom corner? Here's the setup for you. The 1 is the 500 ratio, written as a fraction. Then the fall is simply going to be the 16.4 metres that the gutter needs to travel, multiplied by this 1 on 500 drop that has to occur, times that all out, that many metres. So the gutter from beginning to end needs to drop about 3.3 centimetres. So between this example and this example, you'll have everything you need to be able to work yourself through exercise 12.2. So best of luck with that.